The topic of my today's lecture is Water Part 4. In this lecture, I have discussed the ion exchange method of removal of hardness. I am Dr. Sangeeta Krishnan. So, first we start with the topic of hardness. So, hardness is a condition where the soap becomes ineffective and instead of producing lather, which does the cleaning action, it starts producing a scum or a PPT. Now, in the slide, you can see a diagram, a photograph where you have two liquids, and in one we have hard water, which is turbid, and in the second we have clean water or soft water. Next, we understand the concept of type of hardness. So, hardness is basically of two types. It is temporary hardness and permanent hardness. The temporary hardness is due to the carbonates and bicarbonates of calcium and magnesium. So, four compounds are responsible for temporary hardness and it can easily be removed on boiling. So, it is calcium carbonate, magnesium carbonate, calcium bicarbonate, and magnesium bicarbonate. The second type of hardness is permanent hardness. Now, this is the type of hardness which cannot be removed on boiling. It is there due to the chlorides, sulfates, and nitrates of calcium and magnesium. So, the substances responsible for permanent hardness are calcium ion, magnesium ion, calcium chloride, magnesium chloride, calcium sulfate, magnesium sulfate, calcium nitrate, and magnesium nitrate. Now, these are the questions that are there on ion exchange method. It is what is hardness and its type. Discuss ion exchange method in detail with the well labeled diagram. Now, first we will explain hardness, then we will explain the principle, and later on in detail the various reactions of ion exchange methods with the well labeled diagram. Next are the methods to remove hardness. So there are basically several methods. We will be discussing three methods for removal of hardness. They are lime soda method, ion exchange method, and the zeolite method. In my earlier lectures, I have already discussed lime soda process and also the ion exchange process and also the zeolite process. In this lecture, we will be discussing about the ion exchange process. Now first we understand the meaning of the word ion. So ion can be a single element or a group of element which has a charge. And since there are two types of charges, positive charge and negative charge, hence ions are also of two types. We will understand it with some example. Like first we start with the positive ion. So we have sodium ion, which is a single element, and we can also have an ammonium ion, which is NH4. Talking about the negative ion, we have a chloride ion and a sulfate ion. Basically, ion is something which has it could be a single element or a group of element, but there should be a charge on it. And since there is a charge, so we have two type of ions, positive ions and negative ions. Similarly, next we will do the type of exchangers. So they are basically two type of ions. So there are two type of exchangers. We have a cation exchanger and we have an anion exchanger. We will discuss both of them in detail. First of all, we start with the cation exchanger. So cation exchanger is represented by Rh positive, where R is a complex substance and it is not exchanged. And since the name is cation exchanger, so in this the cation or the H ion is exchanged. It is known that the problem of hardness is there due to two positive ions, that is calcium ion and magnesium ion. So the reactions are as follows. As you can see, we have RH, it reacts with calcium ion. So as a result, the calcium ion gets attached to the complex R and H ion is released. Same is the reaction with magnesium ion. RH reacts with magnesium ion, as a result an exchange takes place and magnesium attaches with the R group. Since the valency of R is 1, so we have R2 magnesium and H ion is released. Next we will see the reactions of cation exchangers. After cation we will see the anion exchanger. Now as the name suggests, anion exchanger, so here the negative ion is exchanged. It is represented by ROH negative, where R is a complex and it is not exchanged and only the OH group is exchanged. It is known that the hardness is caused due to 5 negative ions, namely carbonate, bicarbonate, chloride, sulfate and nitrates of calcium and magnesium. Hence, 5 reactions are shown where the reaction takes with ROH and these ions are exchanged. So the first reaction is between ROH and Cl. So as a result, we have RCl is formed and OH ion is released. In the second reaction, we have ROH reacting with a carbonate ion. So as a result, R2CO3 is formed and again a OH group is released. Next reaction is with a bicarbonate ion. So ROH reacts with a bicarbonate ion and as a result we have RHCO3 is formed and OH ion is released. And the next reaction is with sulfate ion. So ROH reacts with the sulfate ion and as a result R2SO4 is formed and OH ion is released. The last reaction is with the nitrate ion. So ROH reacts with the nitrate ion and as a result RNO3 is formed and OH ion is released. Now it is known to us that from the cation exchanger H ion is released and here in all the reactions OH ion is released. So H combines with OH and as a result water is formed. Now the reactions are also actually of two types. These were the reactions that were the reactions of softening. Now we will do the second category of reaction, which is the regeneration reaction. As the cation exchanger was originally RH, but because of its reaction with calcium and magnesium, the compound that were formed were R2 calcium and R2 magnesium. So again they have to be regenerated to RH. Now for this purpose the H ion, it is made to react with H ion and as a result the two reactions are as follows. The first reaction is with R2 calcium reacts with H ion, that is HCl is passed, and the compound that is formed is again RH, and calcium ion is released. And since it is HCl that is pumped in, so as a result we have a solution of calcium chloride forming. Similar is the reaction with magnesium ion. RH is there, R2 magnesium is there. It reacts with H ion, and as a result again RH is formed and magnesium is released. To generate the H ion, HCl is used, so calcium chloride and magnesium chloride are formed. The second set of reactions are done in the anionic exchanger, where again the react by removal of the hardness, the anionic exchanger, which was originally ROH, by reaction with negative ion, it gets converted into RCl, RNO3, RHCO3 negative, R2SO4, and RNO3. Now this is made to react with NaOH solution, and as a result the compounds that are formed are, first reaction is with R2SO4, it reacts with OH ion, and as a result we get ROH and sulfate ion is released. Next we have RNO3, it reacts with OH ion, and as a result again ROH is formed and the nitrate ion is released. Next we have RCl, it reacts with OH ion, and as a result we get ROH and chloride ion is released. Similar is the reaction with R2CO3. It reacts with H ion, and as a result we get ROH and carbonate ion is released. Then similar is the reaction with bicarbonate ion. RHCO3 is there. It is reacts with OH ion, and as a result again ROH is formed, and ultimately ROH gets regenerated. Now next we will see the instruments that are used for such a reaction. Now this is a diagram. As you can see, on one side by the red dots you can see there is a solution of NaOH. On the other side, which is shown by a blue dot, we have a solution of HCl. In the center we have a cation exchanger, and on the other hand we have an anion exchanger. So first, as you can see from the top, the hard water is passed. So as the hard water passes and it falls down and it passes, the hard water contains calcium and magnesium. It is made to pass through the cation exchanger. So the cation exchanger is nothing but RH. So here a reaction takes place between RH and calcium and magnesium, and as a result by continuous passing, the cation exchanger releases H ions, and R2 calcium and R2 magnesium are formed. Now this H ion along with the remaining water passes into the second portion where we have the anionic exchanger. So the anionic exchanger is ROH. So here when the solution passes, which contains H ion, so as a result, and of course the negative ions are there as it passes through. So as a result a reaction takes place, and ROH reacts with, if there is a carbonate ion it will react with the carbonate and it will convert into RCO3. If there is a bicarbonate ion, then we will have ROH will react and bicarbonate will go into the solution, that is RHCO3 will be formed and OH ion will be released. If there is a chloride ion, then ROH will react with Cl and as a result RCl will be formed. If you have a sulfate ion, then the sulfate ion will react with ROH, and as a result R2SO4 will be formed and OH ion will be released. Lastly, if there is a nitrate ion, then ROH will react with the nitrate ion, and as a result it RNO3 will be formed and OH ion will be released. Now from the cation exchanger H ion is coming, here OH is formed, so H and OH react together and water is formed. Now this softening reaction will continue for some time. After some time, the exchanger will become contaminated, so the reaction has to be stopped. Now from the first pump in the cation exchanger, now again in the cation exchanger HCl has to be pumped. So HCl will be pumped, so the cation exchanger has become R2 calcium and R2 magnesium. So when a reaction takes place, then the R2 calcium and R2 magnesium reacts with HCl, and as a result the calcium and magnesium converts into calcium chloride and magnesium chloride, and H ion again replaces the calcium magnesium and converts into RH. So in this way the cation exchanger is restored. Now in the second chamber where the anion exchanger is formed, and by continuous hardness removal it has converted into RCO3, RH, R2CO3, RCl, RNO3, R2SO4, RHCO3 negative, it has formed. So this reacts with a solution of, now the OH atom has to be restored. So this is made to react with NaOH solution. So when NaOH falls onto this negative ion, sodium salts are formed. So we have a sodium carbonate, a sodium sulfate, sodium nitrate, sodium bicarbonate are all formed, and the anionic exchanger again converts into ROH, and in this way now the reaction is restored. All the both the anion and the cation exchangers have been restored. So the cationic exchanger is now RH, and now the anionic exchanger is ROH. Now again the pumping of the NaOH and HCl is stopped, and again this is washed with water. So whatever sodium salts are formed or calcium chloride and magnesium chloride is formed, it is washed off, and now this is ready for a new sample of hard water. So in this way, using these two uh, compounds, the cation exchangers, the again the reaction will start. I thank you very much for listening to me. I hope you have understood the ion exchange method for removal of hardness.